of the course. We are going to look at the quotient rule today here, and quotient is another word for fraction. And when we have our function given to us as a numerator and denominator, that's obviously going to be a fraction. Now, you can find the formula uh, for tackling these kind of problems in the formula booklet given to us as in as it is in this. Before we get to that, before we get to using that, I would like to show you a proof of why it is the way that it is. So, from previous lecture, we remember the product rule here. Given, I've written it here in the right hand side in red. So, if we think of our function u of x and v of x, we can rewrite this as v of minus 1 multiplied by u of x. So, rewriting that, we'll get such expression. These two are equivalent expressions, I'm sure you agree with me. So, if we try to, now this is a product, right? So we can apply the product rule here, and what we know is that v of x is a kind of a product, is a function that has a power on itself. So we need to actually use the chain rule when you differentiate that. So we're going to apply the product rule to this expression now. So when we do that, we're going to have u dash of x multiplied by vx to the power of minus 1, and we will have u of x multiplied by the derivative of vx to the power of minus 1. Now, this derivative, I've just written it as a dash sign there. Now, if you think carefully about that, how can we find the derivative of v of x to the power minus 1? The minus 1 will come at the front and multiply, and we have to subtract 1 from the power. So we will have minus v of x to the power of minus 2 multiplied by the derivative of inside, which abstractly is going to be v dash of x. So we'll get this expression here. And now we can do some tidying up here. If we bring the minus 1 to the front of this term here and put the power of minus 2, rewrite it as positive 2 in the denominator, we'll get this expression here. Okay, so it looks a little bit neater. Now, these two fractions aren't quite addable or subtractable from each other at the minute, but we can find the common denominator and rewrite it in a little bit neater fashion. So the first term on the left here, if we multiply the top and bottom by another vx, we will have a common denominator of vx to the power minus 2. So we can do that. We end up with this expression here. Okay? And now that we have v to the power of minus 2 in the denominator, we will just write it as one fraction. Okay, so this is where the rule comes from. Now, it's important that whatever you label as your denominator, usually we're gonna use the letter v for the function in the denominator. The order of the numerator is very important, that we start writing vx multiplied by u dash of x and subtract the v dash times by ux, because that's the order. We have to preserve this order in our work, otherwise we are not going to have the right answer. With product rule, because of addition sign, it wouldn't have mattered which order we write the final answer, but in quotient rule the order is actually very important, and that's exactly what you would see here. The denominator was originally g of x. Now order is preserved there as well. Okay, so let's look at some examples when we apply the quotient rule here. So we're going to our expression ux as x, and we're going to call our denominator, the function in the denominator is 2x plus 5, and we're going to find the derivative of ux with respect to x. All right, so that's going to be simply 1, and v dash of x is going to be simply just 2. Right, so we said that the order does matter, so the final dy by dx is going to be v multiplied by, well, v of x multiplied by u dash of x, subtracting v dash of x divided by u of x, and all that will have to be divided by vx squared. Alright, so substituting these into that expression there, we'll have to write 2x plus 5 multiplied by 1, which I'm going to leave out because multiply, alright, actually, let me put it there, and we're going to have subtraction of v, this is a v by the way, so there's a v dash of x, which is 2 multiplied by u of x. So that's basically just 2x, and the square in the denominator is 2x plus 5 there. So multiplying out this bracket, 2x minus 2x is going to cancel away. We will have just simply a 5 on top of the denominator. I forgot about the square in the denominator. And if you want to expand the bracket there in the denominator, you can. We have 2 times 5 times 1 over 2 will give us 20x, and finally 25. So there is the answer there. Alright, so that's, by the way, that's the x. That's all the question is asking you. So let's look at the next example. Alright, so in this example, we have sine of x on top of e to the power of 2x. And what we are asked to find is a stationary point. Okay, the meaning of a stationary point is when dy by dx, we have to figure out what this expression is and set it equal to 0 to solve for the coordinate of p. Alright, so once we've set this expression equal to 0, we can figure out what the value of x is, and once we know what x is, we can substitute it back into this function to figure out what y is. So that's what the overall direction that we're going to do to solve this problem, the path we're going to take to solve this problem. But we're going to have to apply the quotient rule obviously here. So the function on top of the fraction is sine x, and the function in the denominator is power of 2x. So the derivative of sine x is simply cos of x, and the derivative of e to the power of 2x is 2e to the power of 2x. Now the dy by dx will equal to e to the power of 2x multiplied by u dash, which is cos of x here. Now we're going to have to subtract v dash of x, which is 2e to the power of 2x, multiplied by sine of x, and in the denominator we'll have e to the power of 2x squared. Now what you notice here is that every term in this fraction has a common factor of e to the power of 2x. So actually, we can cancel away that power of 2x because it's a common factor on the top. You can cancel these factors away with this square in the denominator. So the simplified answer is actually going to be cos of x minus 2 sine of x. And when we have this expression, we said we're going to set it equal to 0. So on the next line, if I have cos of x subtracting 2 sine x all over e to the power 2x equal to 0, well, the denominator is not going to be 0. E to the power of 2x never approaches 0, no matter what value of x you choose here. It will if you use a real negative value, very small value there, uh, it will approach 0, but it will not be 0. So the only answer, the only way it can be equal to 0 is when the numerator is equal to 0. That means cos of x must equal to 2 sine of x there. And if we try to solve this equation using your knowledge of trigonometric equations, when we have sine of x divided by cos of x, we will get tan here, and that 2 there, we will divide both sides by 2. So in the end, we'll have to solve tan of x equals to a half. Now, if you look at the range of values that the domain of this equation is in terms of show your calculators in radians when you take tan inverse of a half, and that should give us an answer of, very quickly, let me type that in my calculator. So that gives us x is 0.4632, well, 36 actually, to 4 decimal places. So make sure this is the x value of p, and we want to know what's the y value of p. So we know now x value is well, tan inverse of half, and y value would be sine of this decimal number divided by e to the power of 2 times that number, which I will tell you. Right, so the answer was 0.77, 0.177 here. So the answer was 0.177 for the y value. So the coordinate to 3 significant figures is 0.4644, because the 3 will round up, and the y value is 0.17 of the course. Sin of x over cos of x, our u is sine of x, which we know its derivative is cos of x, and v, our denominator, is cos of x, whose derivative is negative sine of x. So putting those together into the formula, v dash is going to be cos square of x. We will have v first. V is cos of x multiplied by u dash, which is another cos of x, right? And we need to subtract the value of u multiplied by v dash. So This product gets a minus sign in front of it. This product gets a plus sign in front of it. Okay, so if you want some notational, we we've had uh, the plus sign. The negative is s- sine of x multiplied by negative sine of x. Now, these two negatives, once we multiply them out, will give us a positive here. So this minus sign multiplied by another negative sign will give us actually, if I try to tidy things up, at the front I'll have positive square, and then at the back I'll have positive sine square. Now, if you remember your trigonometric identities, the numerator here simplifies to 1, no matter what the angle is. So we'll have basically 1 over cos of x, which can be written in another words as secant of x squared, right? So our dy by dx, whenever y is tan of x, is secant of x. So with that, I'll see you in the next video.